Hello, everyone. Welcome to Unit 3. Today, we're going to go over pairs of angles. We're going to look at the different types of angle pairs, and then we are going to do a little drag and drop activity to make sure that we know what we're talking about. So, we're going to start with adjacent angles. And adjacent angles um, have a common side and a common vertex. And remember, the vertex is the closed part of the angle, but no common interior points. So, simply put, adjacent angles are beside each other. So, on this example right here, we see that angle 1 and angle 2 share this line right here in the middle, this wall part. So we know that angle 1 and angle 2 are adjacent to each other or are beside each other. So if you want to think about it, adjacent angles are like side by side, like townhomes or apartments. They share a wall. Now, vertical angles are two non-adjacent angles formed by two intersecting lines. They do not share a side, only a vertex. So, simply put, these angles are across from each other. So, if we look at these two lines here that kind of form this X, we can see that angles 3 and 5 are vertical angles or across from each other, and 4 and 6 are vertical angles. They're across from each other. Well, here's another fun fact. If these angles are vertical or across from each other, they're always congruent. So the measure of angle 3 and the measure of angle 5 are the same measure. The measure of angle 4 and the measure of angle 6 are the same measure. Whatever they are, I don't know. But I know that they're the same. So a linear pair. A linear pair is an adjacent angles whose non-common sides are opposite rays. And so these two angles come together to form a line. So we have angle 7 here, which is an obtuse angle, and angle 8 here. And if you add this angle together right here on 7 and this little angle together on here on 8, they're forming a straight line. And a straight line is 180 degrees. So we know that whatever this angle is plus whatever this measure is, it equals 180 degrees or makes a straight line. So pair means two, and linear means having to do with the line. So remember, a linear pair is two angles that make up a line. Our next type of angles are complementary angles. And complementary angles are angles that have a sum of 90 degrees. And each angle is called a complement of the other. So these two angles over here are complementary because 62 plus 28 is 90 degrees. These two angles are also complementary, and we know that they add up to 90 degrees because we've used our little box in the corner to mark that that's a right angle, and right angles are 90 degrees. Excuse me. Complementary angles do not have to be adjacent. Um, these are not adjacent. They just have to add up to 90 degrees. So now we have supplementary angles. And supplementary angles are angles that have a sum of 180 degrees. Each angle is called a supplement of the other. So down here, we have an angle that's 44 degrees and an angle that is 136 degrees. Well, these are supplementary because if you add 44 and 136, you get 180. You can tell that these two angles right here are supplementary because if you add this angle together and this angle together, it's going to give us our straight line right here. Supplementary angles do not have to be adjacent. And supplementary angles can sometimes be linear pairs, just like this. It created a linear pair. So, how do you solve problems with pairs of angles? Well, in the figures below, you want to set the expressions equal to solve for the variable. And you have to be careful because you have to look and be sure that the angles are equal in order to do this. Saying that they look equal doesn't really count. So ask yourself before beginning, are the angles given in the individual figures below equal? You have to be sure. So if we look at this first one, are the angles in this figure equal? We have 52 degrees, and then we have 3x plus 8. Well, we know that this is going to be a right angle, so these are going to be complementary. So we know that complementary angles equal 90 degrees, so we can say that 52 plus 3x plus 8 equals 90. Well, we can simply do 52. We want to subtract 52 from both sides. 90 minus 52 is 38. Well, we don't even have to go any further. 52 and 38 are not the same. So no, the angles given are complementary, but they are not congruent. So 52 degrees plus this is going to give us 90 degrees, but they're not going to be congruent. They're not going to be both be 45 degrees. And over here on this one, well, these two angles line up, and it looks like they're going to be supplementary. It looks like they're going to give us, so they're going to give us 180 degrees. So we can say that 137 degrees plus x minus 2 equals 180. Okay, super duper. But are the angles going to be congruent? Well, we know that we're just trying to get to 180, so we can say 180 minus 137. Well, 137 plus 137 is way more than 180. So we know that those two angles are not going to be congruent. Because if they were both congruent, they would both equal 90 degrees. So let's look at this third example. We're looking at vertical angles. And vertical angles are across from each other. And so we already said that vertical angles are always congruent. So 123 degrees is 3x degrees, whatever. So these vertical angles are always congruent. So, in conclusion, complementary angles can be congruent, but most of the time they're not. So if your figure shows complementary angles, you add the angles and set them to equal 90 degrees. Supplementary angles can be congruent, but most of the time they're not. If your figure shows supplementary angles, you add the angles and set them to equal 180 degrees. And vertical angles are always congruent, and there's never a time that they're not. If your figure shows vertical angles, they're equal to each other. And vertical angles are across from each other, and they're always equal. So, some examples we have here is we're going to find x in each of the following problems. So, these are the same problems we had on each of our pages earlier. So, for the first one, we already said that 52 plus 3x plus 8 is going to give us 90 degrees. So, right here we have set our problem up. 52 plus 3x plus 8 equals 90. Well, let's combine like terms. Let's get all of our digits together. So we have 52 and 8 is 60, and we still have 3x. So to get rid of the 60, we're going to subtract subtract 60 from both sides. 90 minus 60 is 30, then we got our 3x. 3x is really 3 times x, so we're just going to divide by 3, so x equals 10. Now come over here to number 2. We know that x minus 2 plus 137 is going to give us 180 because these two angles right here form this line, and a line is 180 degrees. So x plus 135 equals 180 degrees. So we're going to combine these terms. So negative 2 plus 137 gives us 135. X plus 135 equals 180. We're going to subtract 135 from both sides. That gives us our x, and x equals 45. And our last one. So we know that adjacent angles are the same, are equal. So we can say here that 3x is equal to 123. Well, we're just going to divide through by 3 to get our x by itself, so x equals 41. So here's a little bit of your turn time. Use complementary, supplementary, and vertical angles to find each missing angle below, and enter your answers as numbers only. So let's look at the measure of angle A. And A is going to be right here. So we have two angles right here, side by side, that are forming a straight line. So that's going to equal 180 degrees. Well, we know we have part of it. We have 130. So we're going to take 180 minus 130 to give us the measure of angle A. And 180 minus 130 leaves us with 50. So A is going to equal 50. Okay, well, we've got that far. Now, let's look at B. Well, we have B right here. We know that angle A is 50, and A and B are side by side right here, and they're going to make up this line, so they equal 180. But you know what else? We already know that angle B and this angle right here are adjacent from each other, and adjacent angles have the same measure. So this angle was 130. This angle was adjacent, so it's going to be B is going to be 130, and we can check that because angle A we solved and it was 50. Well, angle A and angle B form a linear pair, and it's going to be 180 degrees. So 50 subtracted from 180 gives us 130. Gives us 130. Here we go. And now we have C, the measure of angle C. Well, we can look at it two ways. We've already solved for angle B, so we know angle B is 130 degrees. We know that angles B and C right here are forming this line right here. So they're a linear pair. So if we add them up, they're going to be, 180 degrees. But we also know that adjacent angles, or angles that are across from each other, have the same measure. And we've already solved this for A. A is 50. So A is 50, so C is going to be 50. And we can check that because we solved for B, and B is 130 degrees. And we know that B and C added together give us 180, and 180 minus 130 is 50. So we just solved for A, B, and C with only knowing this one little angle. Perfect. I'll let you work through the rest. We're going to apply the same concepts. F and E are adjacent. D and 84 are adjacent. If you look up here, it tells us that this angle right here is a right angle. So this means that this line right here and this line right here are perpendicular. Two lines that are perpendicular form a right angle. So this tells us that this angle is 90 degrees and this angle is 90 degrees. You know what it also tells us? That these two angles added together is 90 degrees, and these two angles together equal 90 degrees. So perpendicular means forms right angles. So for example, two lines that are perpendicular, they form right angles. Just like here we have line N and M, and right here we mark that at each angle that they form is 90 degrees. So we can say that line N is perpendicular to line M, and this is the notation for perpendicular, this little upside down T. And if you're told that the lines are perpendicular, you can label them just like we did here on this example with 4 right angles. So you know that each of these is going to be 90 degrees. So, just like you've done in the past, you've got 2 slides of a total of 6 problems that you are going to solve. So each one says solve for X. You've got an adjacent angle, you've got a linear pair, you've got complementary angles. Here again, adjacent angles, linear pair, and a complementary angle. You're going to use these tiles to cut and paste and go put the answer in on each one. That is your assignment for today. If you have any questions, please let me know. Remember, I'm going to go back to the slide right here. So remember that complementary angles, complements, it's always right to give complements. So a right angle is 90 degrees. Remember that. So complementary angles add up to 90 degrees. Supplementary angles add up to 180 degrees. And a linear pair adds up to 180 degrees. And vertical angles are always congruent, always. So they always equal each other. And let's make sure we remember, in a vertical angle are angles that are across from each other. They don't share a side, they're across from each other. All right, guys, that's all I have for you today. If you have any questions, Please let me know. Have a great one.